Okay, question 1. What does A intersect B represent in P A intersect B? So let's pretend we had A and B. This is A, this is B. And the intersect is the area where they both are. So it's this area in the middle. So that is the probability of A and B. So this is the answer. So let's just go through A union B. What would that be? So if this is A and this is B, A union B would be the whole thing. So A or B. But the answer for this one is A and B. Okay, question 2. P is at the point 4, 9 and Q is the point -2, 1. Circle the midpoint of PQ. Okay, so let's say we've got 2 points. Let's write down where P is. P is 4 on the x-axis, so it'll be 1, 2, 3, 4, and then it'll be 9 up. So let's pretend it's somewhere about here. So this is the point 4, 9. And Q is -2, 1. So that will be -2 here, and then 1 up will be here. So this is -2, 1. So we want to join these two together and find the midpoint here. So it's going to be this point here. So the midpoint will be halfway between the x values. So what's the midpoint between -2 and 4? So the point between those two is going to be 1, isn't it? So we found a midpoint. It's going to be this one. And we can check by finding the midpoint of the y value, so it'll be the number between 1 and 9. So what is the midpoint of 1 and 9? Well, add them together, divide them by 2, you're going to get 5, which is this one. So the midpoint is 1, 5. Okay, question 3. Which of these is a geometric progression? Circle your answers. So geometric means we multiply each term by the same thing to get to the next number. So let's look at this first one. How are we progressing through this sequence? What's happening each time? Each time we're adding 2, aren't we? So for the first one we're adding 2, so that's not a geometric progression. Remember, geometric is multiplying by some value. So what's happening in the next one? So in this one we add 2, we add 3, add 4, right? So we're not multiplying, so it's clearly not this one. What about the next one? We're adding 3, adding 4, adding loads, adding 7 that time. So we're not multiplying, are we? So it's not this one. Okay, but what's happening on this final one? How do we get from 1 to 3, from 3 to 9, 9 to 27? So what we're doing here is we're timesing by 3, timesing by 3, timesing by 3. And because we're multiplying, that means this one is a geometric progression. Question 4. The bearing of A from B is 310 degrees. Circle the bearing of B from A. Okay, so let's draw out our points. So it's A from B. So let's do point B first. So let's say this is B. So A from B is 310 degrees. Okay, so we want to go all the way around the circle to 310, which is about this far. Okay, so this is our bearing, A from B. So that means A is going to be about here. So we want to find the bearing B from A. Okay, so here's north. B from A is going to be this angle here. So what's this going to be? This angle here is going to be, well, the whole thing is going to be 180 minus 50, isn't it? Which is going to give us 130 degrees. So the answer is this one. Okay, question 5. A circle has a circumference C and a diameter D. So the circumference is C, the diameter is D. C equals KD. Okay, what value does the constant K represent? Okay, so how do we get the circumference of a circle from the diameter? So we know C is going to equal the diameter times by something. So what is K? So K is going to be pi. So we can put pi as the answer down here. Question 6. Here is some information about 20 trains leaving a station. So we've got the number of minutes late here, the amount of trains the midpoint. Work out an estimate for the mean number of minutes late. Okay, so what we need to do here is the first thing we're going to do is find the midpoint of the number of minutes late. So what's the midpoint here? What is the middle between 0 and 5? So the midpoint is going to be 2.5. What about the next one? Midpoint of 5 and 10. That's 7.5. Next one, midpoint of 10 and 15. That's 12.5. Last one is t bigger than 15. Okay, we can ignore that because there's no trains, so we can cross that out. Okay, so now we need to find out the number of trains times the midpoint. So we're going to call this f of x. No, we're going to call it f times x. So the number of trains, 12 times 2.5. What are we going to get here? What's 12 times 2.5? So you can use a calculator because it's a calculator exam. So for that you're going to get 30. What's 7 times 7.5? That's going to be 49 plus 3.5, so that's going to be 52.5. 1 times 12.5, that's going to be 12.5. And now we want to work out the total number of trains. So we know that is 20 because the question gives it to us. So we also need to add together all of these here. So what are we going to get? So 30 plus 52.5 plus 12.5 is 95. Okay, so now we've got the number of trains and we've got the total number of minutes late. So we need to do 95 over 20. So 95 divided by 20 equals 19 over 4, which is 4.75. So 4.75 minutes late. That is your answer. Also, it's asking for it in minutes. So this is fine, but we could also give it in minutes and seconds. So this would be 4 mins and 45 seconds. Okay, 6b. The station manager looks at the information in more detail. Okay, so he's taken the same information and he's made these bits smaller. He's made the gaps in the column smaller. So he works out an estimate of the mean using this information. How does his estimate compare with the answer to part A? Tick one box. Okay, so let's compare this bit to this bit. So it's the same amount of trains. You can see there's still 12 trains here and there's 12 trains here. But if we were to make a midpoint, what would our midpoint here be? So between 0 and 2. Your midpoint is going to be 1, isn't it? So you've got these trains, the average minutes late is going to be 1. But here, the midpoint is 2.5. So what does this tell you about the average minutes late the train is going to be? So I think it's going to make it lower than part A. Because we've got 12 trains which they are averaging 1 minute late. But on this side, you had 12 trains and they were averaging 2.5 minutes late. Okay, so the answer to this one is lower than part A. Okay, question 7. Work out the values of A and B in the identity. So, we want to find A and B. How can we do this? Alright, let's try to simplify the left-hand side. So let's multiply out these brackets. So we're going to get 5 times 7x, that's going to give us 35x, plus 8 times 5, which is 40, plus 3 times 2x, which is 6x, plus 3 times b, which is going to be 3b. And that equals to ax plus 13. Okay, so let's simplify this side. Let's put our x's together. So we're going to get 35 plus 6x, which is 41x, plus 40 plus 3b equals ax plus 13. Okay, so let's get these all sorted out a bit more. So we're going to get 41x, let's move the 40 to the other side, plus 3b, moving the 40 over, we're going to get 13 minus 40. So 13 minus 40 is minus 27, so it's going to be ax minus 27. Okay, so now we can compare the two sides of this equation. So we've got 41x is equal to ax. So from this bit we can see that 41 is going to be equal to a, and then this bit 3b is going to be equal to minus 27. So we can rewrite this as a new equation. So 3b equals minus 27, so that's going to imply b is going to equal minus 9. So just remember to write your answers in the proper box. Okay, question 8. Two identical quarter circles are cut from a rectangle as shown. Work out the shaded area. Okay, so we've got two quarter circles. So we can work out that this length here is going to be 6. So we can work out the area of this bit here. So this is a quarter of a circle, but we're going to save some time and we're going to do both of these quarters at the same time. So we know we've got to work out the area of a semicircle like this, of radius 6. So what's the area of a circle? So area of a circle is pi r squared, but we only want half the area, so we're going to divide it all by 2. So area of half circle. So that's going to equal pi times the radius squared. The radius is 6, so it's going to be pi 6 squared over 2 is equal to pi 18. That's it. Not pi 18. No one writes that. 18 pi. Okay, so that's the area of the circle. So it's this area and this area. So now we need to do the rectangle area minus the semicircle area. So the rectangle area is 12 times 6, and we've worked out the semicircle area, which was 18 pi. So put this into your calculator or do it in your head. You're going to get 12 times 6 is equal to 72 minus 18 pi is going to give you, let me see, 15.45 centimeters squared. And that is that for question 8. Okay, question 9. The diagram showed the position of the tap when it's fully on and fully off. The tap is fully on when the angle of the turn is 180 degrees. When fully on, water flows out of the tap at 14 litres per minute. The rate at which the water flows in and out is in direct proportion to the angle of the turn. So what that means, if the tap was turned half on, it would only flow at half the rate. So for example, if it was half on, it wouldn't flow at 14 litres per minute. It would flow at 7 litres. But that's just an example. So it says the rate at which the water flows out is in direct proportion to the angle of the turn. The tap is turned on 135 degrees. Okay, so 135 degrees. What proportion of that is that to 180? So we can do 135 over 180. What's that going to give us? 135 divided by 180, use your calculators, is equal to 3/4 or 0.75. Okay, so we know the proportion of which it's on. So it says the water flows into a tank with a capacity of 79.8 litres. Will it take less than 7.5 minutes to fill the tank? You must show your working. Okay, so when the tap is fully on, the flow rate, which we're going to call FL, no we're not, we're going to call it FR, flow rate is equal to 14 litres. But we know the tap isn't fully on. We know the tap is only on at 3/4 of the speed. So it's only flowing at a rate of 3/4. So we need to know 3/4 on. The flow rate is equal to the total flow rate, which is 14. So we're going to write 14 times the proportion, which is 0.75. So 14 times 0.75 gives us 10.5. So we know 10.5 litres are flowing in per minute. And we want to find, will it take less than 7.5 minutes? So we're going to do 10.5 per minute times by the amount of minutes, which is 7.5. So we need to do 10.5 times 7.5, and that's giving us 78.75. Okay, this is the total amount in 7.5 mins. So, will it take less than 7.5 minutes to fill the tank? So has it filled the tank after 7.5 minutes? So this number is less than that number, isn't it? So yes, it will. And that is question 9 done. Okay, that's not right, is it? It's not yes, it's no. The answer is no. No, it won't fill the tank in that time. Okay, next question. Question 10. This triangle is equilateral. What does that mean? Equilateral means all the lengths, all of these sides are the same. So all the sides are the same length. So, is the perimeter of the triangle greater than 1 meter? So we want to find out if this plus this plus this is bigger than 1 meter. Okay, so what do we know about the sides? We know that all of them are equal. So we've got 3 different equations we can use. So let's find out what x is, and then we can use that to find out. So 6x minus 10 is going to be equal to 4x plus 5. So let's find out what x is. So we're going to get 2x by moving 4 to the other side, and then move the 10 to the other side. We're going to get 2x equals 15. So x equals 7.5. Alright, now let's substitute this x into here. So 6 times 7.5 minus 10 is equal to what? So that would be 45 minus 10 equals 35 centimeters. So we know one side equals 35 centimeters, but there isn't only one side, there's 3 sides. So 3 sides is going to equal 35 times 3 equals 105 centimeters. So is the perimeter of the triangle greater than 1 meter? So 105 centimeters is bigger than 1 meter, so yes, the perimeter of the triangle is greater than 1 meter. Okay, question 11. An approximation for the value of pi is given by this big sum. Use your calculator to show that this approximation is within 0.1 or 3.14. So, all you need to do here is put this into your calculator. Make sure you're careful, check all your numbers twice. So, when you put it in, you're going to get 3.0418 ... But we're just going to do it to 4 decimal places. And now we need to do 3.14 minus what you got on your calculator. Okay, so let's see if that is within 0.1. So you're going to do 3.14 minus your answer, and you're going to get 0.09, and we are done. Okay, question 12. Work out 9.12 times 10 to the 10 over 3.2 times 10 to the 4. Give your answer in standard form. Okay, calculator exam, put this into your calculator, be careful with it. So, once you've put that in your calculator, you should get 285,000 million. That's not right, it's 2,850,000. That's what this number is. And it says give your answer in standard form. So we want it in the form 2.85 times 10 to the what? How many decimal places have we moved it? So we've put a decimal point here. So it's 1, 2, 3, 4, 5, 6. So it's 2.85 times 10 to the 6. Then put your answer in the correct place. Question 13. Ashraf is going to put the boxes into a crate. The crate is a cuboid measuring 2.5 by 2 meters by 1.2 meters. Each box is a cube of length 50 centimeters. Okay, so the volume of the crate is 2.5 times 2 times 1.2, and you get 6 meters cubed. That seems about right. The volume of one box is 0.5 times 0.5 times 0.5, and it gives you 0.125 meters cubed. That seems right. So the number of boxes he thinks is 6 divided by the volume of each box. So it's the volume of the crate divided by the volume of the boxes. So let's draw it out so we can get a nice visual on this. So we've got a big crate like so, and it measures 2.5 by 2 by 1.5 by 1.2. Okay, so that's the big crate, and then he has little boxes to go into the crate, and each side of this is 0.5, 0.5 and 0.5. So he thinks you can put 48 into this big box, so 48 little ones into the big one. Okay, evaluate his method and his claim. I think his method is okay. He's divided the volume of the crate by the volume of the boxes, so that seems fine. But his claim is wrong because he says he can put 48 boxes into the crate. So how can we prove him wrong? So we know the length of the crate is 1.2, right? So we've got a crate, let's draw a cross section here. So this is 1.2 meters. And then we know the width of a box is 0.5. So how many 0.5s can we fit in here? We can fit 0.5 here, and we can fit 0.5 here, and then we've got a tiny little gap, haven't we? So we're going to be left with a gap, and this gap we cannot fill with any boxes because it won't fit. So what can we write? So we can write, I think his method is okay, but his claim is wrong. His claim is wrong because there will be gaps between the boxes because it's not a perfect multiple of the length of the box. So I think his method is okay, but his claim is wrong because they won't fit perfectly. Okay, done. Okay, 14. The cross-section of a prism has n sides. Circle the expression for the number of edges in the prism. So let's pretend we had a triangular prism. So we've got 3 sides. And now we're going to turn this prism into... No, we're going to turn this triangle into a prism. So we've got 3 sides to begin with. So how many edges do we have now? So circle the expression for the number of edges in the prism. So we've got 1, 2, 3, 4, 5, and then there'll be another one behind here, which is 6, and then 7, 8, and 9. Okay, it's a bit hard to see them. So we start with 3 sides and we end up with 9 edges. So how do we get from 3 sides to 9 edges? So what do? We're going to multiply by 3, aren't we? So to get from 3 sides to 9 edges, we times by 3. So the expression is going to be 3n. Okay, this is a bit tricky when you have to draw it out, so just try to visualize the prism in your head. Okay, question 15. The volume of a medal is 45 centimeters cubed. The medal is made from copper and tin. The volume of copper to the ratio of the volume of tin is 22 to 3. And we know the density of copper and the density of tin. Work out the mass of the medal. Okay, so let's do 1 gram of this medal first, because we know, no, not 1 gram, let's do 1 centimeter cubed of this medal. So 1 centimeter cubed of this medal is going to be made up of 22 bits of copper and 3 bits of tin. So let's have a look. So how many bits altogether do we have? It's a ratio, so it's going to be 22 plus 3. So it's going to be 25 and 25. And it's going to be 22 bits of copper. So let's put C for copper, and then 3 bits of tin. So that's the ratio we've got here. So we know the density of copper is 8.96. So let's do 8.96 times by 22 over 25. Okay, so that is copper. And then let's do tin, which is going to be 7.31, which is going to be 7.31 times by its ratio, which is going to be 3 over 25. So get your calculator and put these numbers in. So for copper, you get 8.96 times 22 over 25, which is going to be 7.8848. And this is grams. And then we're going to do the same for tin, which is going to be 7.31 times 3 over 25, which is going to give you 0.8772. Okay, so this is the weight of the copper part and the weight of the tin part. So we need to add these together. So we're going to get 7.8848 plus 0.8772. So put that in your calculator. You are going to get 8848. You are going to get what? 8.762 grams for 1 centimeter cubed of this metal. So now the metal isn't 1 centimeter cubed, the metal is 45 centimeters cubed. So you need to multiply it by 45. So take this and times by 45. And we should get 394.29 grams. So put that in the correct box and you are done. 16. The cumulative frequency graph shows information about the masses of 50 apples. So we've got the cumulative frequency on the y-axis and the mass on the x-axis. Use the graph to estimate the median mass of the apples. So median means middle. So which apple is in the middle? So we've got 50, so we know the middle apple is going to be the 25th. So the 25th apple is here. So go across the graph till you get to this point and then go down, and you can see it is exactly here, which is 106 grams. B. Estimate the proportion of the apples that have a mass greater than 115 grams. So for this one, we're doing the opposite. So we're going to start at 115 grams here, go up the graph till you get to here, and then go across the graph until you get to here. So that is 42. So we want to find the proportion of the apples that have a mass greater than this. So we're interested in this little bit here, which is 8 apples. So we know 8 apples weigh more than 115 grams. So we want to do 8 over 50. And that's it. That's our proportion done. We can simplify it if you want to a decimal. So you can do 8 divided by 50. And you're going to get 0.16. And that is our proportion of apples that weigh more than 115 grams. Okay, question 17. A is a prime number, B is an even number, and n equals a squared plus ab. So, circle the correct statement about n. So we want to find out whether n is even or odd. Okay, so let's think about a. A is a prime number. So prime numbers, let's list them out. So we've got 2, 3, 5, 7, ... So prime numbers can be even or odd, can't they? So what about a squared? So a squared, if a is a prime number, it can also be even or odd. So let's imagine we squared 2. So 2 squared gives us 4. 3 squared will give us 9. So there you go. The first 2 examples, we've got an even number or an odd number. So we know a squared can be odd or even. So let's think about AB. So B is an even number, A is a prime number. So A, B, therefore, can also be odd or even. And then A squared plus AB can also be odd or even. So we know odd plus odd equals even, odd plus even equals odd, and even plus even equals even. So we know that this is going to be, could be even or odd. So this is our answer here. Question 18. A bag contains 20 discs. 10 are red, 7 are blue, and 3 are green. Marnie takes a disc at random before putting it back in the bag. Nick then takes a disc at random before putting it back in the bag. Ollie then takes a disc at random. Work out the probability that they all take a red disc. Okay, let's do the probability of Marnie taking a red disc. So, M for Marnie. So what's the probability of taking a red one? So we know 10 are red and there's 20 discs. So the probability of her taking a red is going to be 10 over 20. And let's do the same for Nick. The probability of him taking a red is 10 over 20. And then the same for Ollie. That's going to be 10 over 20. So we want all three of these to happen at the same time. So what we're going to do is 10 over 20 to the power of 3, which is, well, it's the same as 0.5 to the power of 3, which gives us an answer of 1/8. All 20 discs are in the bag. Reggie takes 3 discs at random, one after the other. He takes a disc. After he takes a disc, he does not put it back in the bag. Okay. Reggie's first disc is blue. Work out the probability that all 3 discs are different colours. Okay, so first disc is blue. So what's the state of the bag after he takes out the blue disc? So let's think about this. So what is left in his bag? So we're going to have, well, 1 blue one's been taken, so there's going to be 10 reds left. There's going to be 6 blue left, and there's going to be 3 greens left. So what we can do now is we can make a probability tree. So we're going to start here. So what is the probability of picking a red one? So let's put R for red, B for blue, G for green. So the probability of taking a red one is 10 over how many discs are left, which is 19 because he took one out. The probability of taking a blue one is going to be 6 over 19. And the probability of taking a green one is going to be 3 over 19. Okay, so the first disc is blue. We don't want another blue disc because we want them all to be different colours. So we can actually get rid of this middle column. Okay, so after we've taken a red disc, we can have 3 more choices. And then after we've taken a green disc, we can have 3 more choices. So let's do red, blue and green again, and then red, blue and green. Okay, so the first one is blue. So he takes a blue one, he takes a red one. Then the last option, he's already got blue, he's already got red, so he can't take these colours again. So we can get rid of red, we can get rid of blue, which means he takes a green one. Okay, so what's the probability he will take a green one? So what's left in the bag? There's 18 discs because he's already taken 2. And how many of them are green? It's going to be 3 because he's not taken a green one yet. Okay, so the probability of him taking a green one is 3 over 18. And now let's do the same for if he took a green one first. So he's taken a blue, he's taken a green. So that means we don't want another green, we don't want another blue, but we do want a red. So what's the probability of him taking a red? So it's going to be 10 because there's 10 red discs. And how many discs are left? Well, there were 20 to begin with, but he's taken 2. So it's going to be 10 over 18. Okay, so now we just need to work out these probabilities. So we have 2 paths down our tree. So the first one is going to be red followed by green, and the second one is going to be green followed by red. So it's going to be 10 over 19 times by 3 over 18. And then the other option we have is green followed by red, which was 3 over 19 times by 10 over 18. Okay, so what we need to do now is put these into your calculator. So for the first one, you're going to get 10 over 19 times 3 over 18, which is going to give you 5 over 57. And then the second one is going to be 3 over 19 times 10 over 18, which is also going to be 5 over 57. Okay, so what we need to do now is we need to add these probabilities together. So you're going to get 10 over 57, and that's our answer, 10 over 57. And that is the probability that all the discs are different colours. Okay, that's everything for 18b. 19. There are 4 starters and 10 main courses to choose from. 2 of the starters and 3 of the main courses are suitable for vegans. What percentage of the possible lunches have both courses suitable for vegan? Okay, so lunch is you choose 1 starter and 1 main course. Okay, so let's talk about the starters. So there are 4 starters and 10 main courses. 2 of the starters are suitable for vegans. So 2 out of 4 starters are suitable for vegans. Okay, let's talk about the main course. So it says 3 of the main courses are suitable for vegan, and there's 10 overall. So 3 over 10 suitable for vegans. What percentage of the possible lunches have both courses suitable for vegans? Okay, so we know the proportion of starters and main courses which are vegan. So we're going to do 2 over 4 times by 3 over 10, which is going to give us 6 over 40. Can we simplify this? We can say 6 over 40 is the same as 3 over 20, which is the same as 0.15, but we want it as a percentage, so that will go to 15% of these lunches are suitable for vegans. 15%. Okay, 20. N is a positive integer. Prove algebraically that this is a cube number. So a cube number is going to be something of the form n cubed. So what we want to do is rearrange all of this to get it to n cubed. So what we're going to do is multiply everything out and then try to simplify. So the first thing is we're going to multiply out the brackets. So we're going to get 2n squared times by 3 over n. And then for the second one, we're going to get 2n squared times n. And then for this bit over this side, we're going to get 6n times n squared minus 6n. Okay, let's do some simplification. So we've got an n here we can cancel. You can cancel this n with one of these n's. So you're going to get 6n plus, what can we do here? We can put all these n's together, plus 2n cubed plus 6n cubed minus 6n. So let's put our n cubes together. We're going to get 8n cubed, and then the 6n's cancel out. And because we've got an n cubed term, we have proven that this is a cube number. Well, actually we need to do one more step. So we need to transform this into the form something cubed, not 8 times n cubed. So we can change this into 2n cubed, because 2n cubed is going to give you 8n cubed. So these two are the same, but we just want to have one thing inside your bracket being cubed. Okay, that's it for question 20. 21. Y is inversely proportional to root x, and when y equals 4, x equals 9. Work out an equation connecting y and x. Okay, so if they're inversely proportional, we know that y is going to equal 1 over root x. But we also need to put in a factor of proportionality. So we're going to put in a factor and we're going to call it k. Okay, so this is our equation. We're going to use this, and now we're going to try and find out what k is. So let's substitute in our y and our x. So we're going to say k y, but we know y equals 4. So k times 4 is equal to 1 over root x, and x is 9, so it's going to be root of 9. So let's see. So 4k is equal to 1 over 3, so 12k is equal to 1, so k is equal to 1/12. So we can substitute this k back into here, and we're going to get our answer. So 1/12 of y is equal to 1 over root x. And that's it for 21a. Okay, 21b. Work out the value of y when x equals 25. So now we're just substituting this into here. So let's rearrange our formula a bit. So let's move this 1/12 to the other side. So we're going to get y equals 12 over root x. Okay, so that means y is equal to 12 over root of x, which is 25, is equal to 12 over 5. And that's our answer, 12 over 5. Done. Okay, question 22. Simplify fully. Okay, so let's start by simplifying the top. So what can we take out of both of these? We've got an x cubed and an x to the 5. So we can take out x cubed out of both of these. So we're going to take an x cubed outside of the brackets. And then what's going to be left on the inside? We're going to be left with an x squared and then a minus 4. So that's the first step. So the top is simplified pretty well, I think. Okay, the bottom one. How can we simplify the bottom? So what can we do? So we can take out a 3, can't we? So we can get 3x minus 2. Is there anything else we can do to simplify this a bit more? Well, we can split this one into a difference of 2 squares. So at the top we're going to split a bit more, so we're going to get x cubed, and then we're going to get 2 brackets on top. We're going to get x plus 2 and an x minus 2. And then the bottom is going to stay the same, 3 times x minus 2. And now we can do some cancelling. So we can cancel this and this. So we're going to get x cubed times x plus 2 all over 3. And I think that is as simple as it's going to get. Question 23. PQR is a straight line. PQ to QR, the ratio between these two is 3:1. So P to Q is 3, Q to R is 1. So we know P to Q, this from here to here is 3, and Q to R is going to be 1. Okay, so we know the vector PQ, equals A. And we want to find the vector RQ. So from here to here, R to Q, what is this in terms of PQ? So PQ is going this way by 3. We want a vector which goes this way by 1. So it's going to be a negative, isn't it? And it's going to be a negative vector which is travelling 1/3 of the distance. So it's going to be this one, minus 1/3 of A. Okay, question 24. Here is a sketch of y equals f of x. The curve passes through these points. Alright, let's label these points. So minus 2, 10 is going to be here, minus 1, 3 here, 0, minus 2 is here. The next one is minus 1, 1, that's here, and 2, 6 here. Okay, on the grid, sketch the curve y equals f of x plus 2. Okay, so this f of x plus 2 means the graph is going to shift 2 units to the left. So all of these points are going to go this way by 2. So we can shift them all to the left, like this. And then what we need to do is we need to join these points with a nice smooth curve. Okay, so in the exam you get points for accuracy, so make sure your curve is nicer than that. Okay, so that's it for this question. Okay, question 25. So ABC and ACD are triangles. Work out the size of angle X. Angle X is this one here. So let's first look at the triangle ACD, which is this triangle here. So we want to find this length. We want to find AC. Okay, so let's recall our trig knowledge. So we know the phrase so ka toa, where we're talking about sine, cos, and tangent. Okay, so what do we know? We want to find AC, which is, what is the relationship between that and D? Is it opposite, adjacent, or the hypotenuse? Well, it's not the hypotenuse because this one is the hypotenuse, which is the longest one. It's not adjacent because it's not next to the angle, so it is opposite. And we have the opposite and we have the adjacent. We know A, we know 16. So we are going to use O and A, which is tan. So we're going to use tan of theta is equal to the opposite over the adjacent, which is, we know opposite, no we don't know the opposite, do we? So let's put x over 16, which is the adjacent side. Okay, so we also know theta, because theta is the 49-degree angle. So we're going to say tan of 49 is equal to x over 16. But let's just move this 16 over to here to save us a line of working. So 16 tan of 49 equals x. Put that in your calculator. What do you get? So once you've put that in your calculator, you should get 18.4. Okay, we're just going to do it to one decimal place to save a bit of time. So we can put this onto our diagram. So this one is 18.4. Okay, so next we want to find this angle x. And what do we know? We have two sides and two angles which are opposite. So we're going to use the sine rule. So the sine rule is this. So sine of A over the length A is equal to the sine of B over length B. So big letters are the angles, little letters are the lengths. So let's substitute in our numbers. So we know sine of 35, because 35 is the angle here, is going to be over 20, because 20 is the length. And that is going to be equal to the sine of x, which we don't know, because that is this one here, which is what we're looking for, over the length we just found, which is 18.4. So we're going to rearrange this to get a function, or to get an expression. So we're going to move the 18.4 to the top, to the other side. 18.4 times sine of 35 over 20, and that's all in brackets, equals sine of x. So we've got one more step. We're going to take the inverse sine of all of the other side, and that's going to give us x. So the inverse sine of 18.4 times by sine 35 over 20. Okay, put this in your calculator, see what you get. Okay, when you put that in your calculator, you should get an answer of 31.85 to two decimal places. You can also write 31.9 and that's fine as well. Okay, question 26. We have two functions, f of x equals x over x plus 2, and g of x, which is equal to x squared minus x. Work out fg of x. Give your answer in the form a plus bx to the power of n, where a, b, and n are integers. So fg of x. So what we're doing here is we're going to put g inside of f. Okay, so the x in our f of x is going to become g. So let's write out f of x. So that is x over x plus 2. But this x is going to become g of x. So this is going to becomes x squared minus 2. And so does this x. So we're going to replace both x's with x squared minus 2. So we can write fg of x is going to equal x squared minus 2 over x squared minus 2 plus 2. So we can do some simplification. X squared minus 2 over, what happens here? These 2's are going to cancel, aren't they? So we're going to get over x squared. But the question wants the answer in the form ax plus bx to the n. Okay, so what can we cancel here? So x squared is going to cancel with x squared. So we're going to get x squared over x squared equals 1. And then we're going to get 1 minus 2 over x squared, which is equal to 1 minus 2x to the minus 2. So that's your answer. 1 minus 2x to the minus 2. And we are done. Alright, question 27. The point 3, 1 over 64 lies on the curve y equals kx, where k is a constant. Show that the point half, half lies on the curve. Okay, so we want to find out what this constant k is. So we're going to substitute our x and our y into this equation. So our x is 3, our y is 1 over 64. So 1 over 64 is equal to k to the power of x, which is 3. So let's try to simplify this. We can take the cube root to the other side. So we're going to get 1 over 64, all cube rooted, equals k. What's the cube root of 1 over 64? We're going to get k equals 1 over 4. So k equals 1/4. Now we want to show that the point half half lies on the curve. Okay, so we can now rewrite this with our k we just found. So y equals 1/4 to the x. And now we can substitute in our point, our x and our y over here, into this one. So we're going to put half equals 1/4 to the half. And we need to verify that both sides of these are equal. So 1/2 equals 1/4 to the power of 2. So put 1/4 to the power of 2 to the power of 1/2 into your calculator, and you should get the same answer. Yeah, that goes perfectly. So 1/2 equals 1/2. Therefore, half half lies on the curve. And we are done. Okay, last one. Question 28. Izzy runs an 80-meter race in 14 seconds. During the first 6 seconds, her speed increases at a constant rate. During the last 8 seconds, her speed increases at a different constant rate. Her speed at 14 seconds is 2 meters per second more than her speed at 6 seconds. Here is a sketch of her speed time graph. So we've got speed on the y, time on the s. Work out her acceleration during the last 8 seconds. State the units of your answer. Okay, so we want to find out her acceleration during the last 8 seconds and state the units of your answer. So we know acceleration, which is going to be a, is equal to the change in velocity. So it's the change in velocity over the time. So let's put change in v over t equals a. So her speed at 14 seconds is 2 meters per second more than her speed at 6 seconds. So the change in velocity here is going to be 2 meters per second. And the amount of time that took is 8 seconds. So it's going to be 2 meters per second over 8. So it's going to be 2 over 8 equals 1/4, or 0.25. But we want to know the units. So it's 8 meters per second over 8 seconds. So the unit is going to be meters per second squared. Okay, 28b. When Izzy finishes the 80-meter race, her speed is v meters per second. Work out the value of v. Okay, so let's write down what we know on our graph. So we know her speed at 14 seconds is 2 meters per second more than her speed at 6 seconds. So we have two different speeds we know. We don't know the exact speed because that's what we're trying to find out. But we know that the difference in the speed is 2. So let's call this one, the top one, x plus 2. Because it's her speed at 14 meters here is 2 meters per second faster. And then let's call her speed at 6. This is just going to be x. Okay, so what do we know about a speed time graph? We know the area under the graph is equal to the distance. So what we want to do is we want to find this area under this graph here. Okay, so how can we do that? Okay, so what we want to do is find out the area under this graph here. So let's write it down. So speed time graph, speed time area under equals the distance, right? So let's find this area. So we've got a triangle and a trapezium. So what's the area of a triangle? The area of a triangle is half base times height. So we know half is going to be a half, and then the base is 6, and the height is this distance here, which we don't know. It's going to be x for now. Okay, and then for the trapezium, this bit, we know the formula for a trapezium is half a plus b times by the height, where this height here is a and this one is b. So let's substitute in what we know. So it's going to be half a, which is going to be 14, plus b, which is, wait, no, it's not going to be 14, is it? It's the height. 14 is going to be on the outside. No, it's not. I've messed it up completely. Okay, half AB, where A and B are the heights. Okay, so this height here is x from here. So x plus the two heights, the other height is going to be x plus 2. So x plus 2 times by the height. And the height is going to be this distance here from 6 to 14, which is going to be 8. Okay, so let's work out the whole area. Let's bring it to the other side over here. So we know that this is equal to the distance. So we know the whole race was 80 meters. So it's going to be 80 is going to be equal to the triangle we worked out plus the trapezium, which is going to be half 6x plus the trapezium, which was half x plus 2 times by 8. So let's do some simplification. So we're going to get 80 equals 3x plus 4 times 2x plus 2. We can do another bit of simplification. 3x equals 8x plus 2. So 11x plus 2 equals 80. Okay, I've made a mistake, haven't I? I've multiplied out this wrong. So this should be an 8, and therefore this should be an 8. So 80 equals 11x plus 8. So let's find out what x is. So 80 minus 8 equals 11x. So 72 over 11 equals x. And that's going to tell us that x is equal to, you can put that in your calculator, 72 divided by 11 equals 6.54. So 6.54 is your x. So that is your speed here. But you don't want this speed, you want this speed. So we just need to add 2 to what we got. So we need to do 6.54 plus 2, and that's going to give us our answer, which is going to be 8.54. And then put that in the final box, and we are done.